Sometimes in life, different people will refer to the same person in different ways. When you talk to your professor, I'm sure you would say something like, "Excuse me, professor, could you possibly?" And then you might continue your conversation. Now, I know all the professors at your university are perfectly charming. So let's talk about another professor that's definitely from another university. Now, they might think they have a higher status than your professor. They might talk to your professor as, "Hey, ugly, come over here." Now, chemistry is the same, but instead of status, we have priority. Functional groups have different priority, and the name we give to the functional group is different depending upon whether it's the highest priority functional group in that molecule or whether it's not the highest priority functional group in that molecule. So now we're going to talk about a list of functional groups in order of priority. The highest priority functional group in our list is cations, such as ammonium, phosphonium, or sulfonium. Now, if they are not the highest priority, if there were another functional group present that were a higher priority than the cation, such as radicals or anions that are not discussed here, then the cation would be referred to as ammonio, phosphonio, or sulfonio. Everything changes if the cation is the highest priority functional group in your molecule. Now, they are described as alkyl ammonium, alkyl phosphonium, or alkyl sulfonium. The alkyl section is generic, and so that's going to be methyl for 1 carbon, ethyl for 2 carbons, propyl for 3 carbons, butyl for 4 carbons, etc., depending on the specific case in question. Okay, so that's cations. The next highest functional group after cations we will address are carboxylic acids. And again, they have 2 different names depending on their priority within a certain molecule. If they are not the highest priority functional group within a specific molecule, for example, there's a cation as well, then they are called carboxy. If, however, they are the highest priority functional group within the molecule, then they're going to be referred to as alkynoic acid. Again, the alkane section is generic. So that's going to be methanoic acid if there's 1 carbon, ethanoic acid if there are 2 carbons, propanoic acid if there are 3 carbons, butanoic acid if there are 4 carbons, etc., depending upon the specific number of carbons in your molecule. There is one other name we might give a carboxylic acid, and that comes about if it isn't part of the main system, so largest number of carbons, where the main system is a ring. The carboxylic acid is thus pendant. Here, for example, we have a cyclopentane. We can see that there is a carboxylic acid in the molecule, but it isn't part of the main system, the ring. So here we call this molecule cyclopentane carboxylic acid. What functional group is the next highest priority after carboxylic acid? That is carboxylic acid anhydride. If it's not the highest priority functional group in the molecule, it's called alkanoxy carbonyl. The alkane is going to change. Again, it's generic. It may be methan, ethan, propan, butan, etc. However, if your carboxylic acid anhydride is the highest priority functional group in your specific molecule, then again the name will change. So now it's alkanoic anhydride. And yet again, the alkane is generic. So that may be methan, ethan, propan, butan, etc. If the carboxylic acid anhydride isn't part of your ring main system, so it's pendant, then it's going to be called carboxylic anhydride. An example has the anhydride pendant to the parent benzene. So this is benzene carboxylic ethanoic anhydride. After the carboxylic acid anhydride, the next functional group down in our list of priorities is ester. If the ester isn't the highest priority functional group in your molecule, it's called alkoxycarbonyl. However, if it is the highest priority functional group in your molecule, the name changes and it's called alkyl OH. But if the ester is pendant, not part of the main chain when we're looking at the carbonyl carbon of the ester, then the name is alkyl carboxylate. Moving on from esters and going down our priority list still, we come to the carboxylic acid halide. That could be fluoride, chloride, bromide, iodide, etc. So, if our carboxylic acid halide is not the highest priority functional group in our molecule, we call it a halocarbonyl. So that could be a fluorocarbonyl, chlorocarbonyl, bromocarbonyl, iodocarbonyl, for example. But if the carboxylic acid halide is the highest priority functional group in your molecule, the name changes again and it's called alkanoyl halide. So alkanoyl fluoride, alkanoyl chloride, alkanoyl bromide, alkanoyl iodide, for example. And lastly, if your carboxylic acid halide is pendant, not part of the main chain, it's called carbonyl halide. So carbonyl fluoride, carbonyl chloride, carbonyl bromide, and carbonyl iodide, for example. Moving on from the carboxylic acid halides, again going down the list of priorities, we come to the amide. Amides, if they are not the highest priority functional group in your molecule, are called carbamoyl. But if they are the highest priority group in your molecule, they're called alkanamide. Where this is pendant, that's to say not part of the main chain, it's called carboxamide. Moving on from amide, going down the list again further, we come to the nitrile group. Where the nitrile group is not the highest priority functional group in your molecule, it's called cyano. If it is the highest priority functional group in your molecule, now it's called alkane nitrile. But if your nitrile group is pendant and not part of the main chain, it's called carbonitrile. Coming down in our list of priorities, we go from nitrile and arrive at aldehyde. But where your aldehyde isn't the highest priority functional group in your molecule, it's described as oxo. But if it is the highest priority functional group in your molecule, well, now it's called alkanal. If it happens to be pendant and not part of the main chain, it's described as carbaldehyde. From aldehyde, we go down in priority and next arrive at ketone. Where ketone isn't the highest priority functional group in your molecule, it, like aldehyde, is called oxo. But if it is the highest priority functional group in your molecule, well, now it's called alkanone. From ketone, we go down and come to alcohol. Where alcohol isn't the highest priority functional group in the molecule, it's called hydroxy. But if it is the highest priority functional group in your molecule, well, now it's called alkanol. Going from alcohol, the next lowest priority functional group is thiol. Now, where thiol isn't the highest priority functional group in your molecule, it's called mercapto. But if it is the highest priority functional group, well, now it's called alkane thiol. Going down from thiols, we come to amines in the priority list. Amine, if it isn't the highest priority functional group in your molecule, is called amino. If it is the highest priority functional group in your molecule, the name changes, and we have alkanamine. From amines going down, we come to alkenes. Alkenes, if they're not the highest priority functional group in your molecule, are described as alkenyl. If they are the highest priority functional group, well, they're just alkenes. From alkenes going down, we come to alkynes. Alkynes, if they are not the highest priority functional group in your molecule, are alkyne with the E dropped or not dropped, depending on different circumstances, and we will go into that. And again, if they are the highest priority functional group, they're going to be called alkyne as well, with the E present. If they're pendant, they're alkynyl. Lastly, we come to alkanes, but it's not just alkanes. Certain functional groups aren't given priority beyond an alkane. They include nitro groups, as well as halides that are given the prefix halo, and ethers that are described as alkoxy. So that's a list of some very common functional groups and where they lie in priority in terms of naming. The priorities are not chemically based. It's nothing to do with any sort of chemistry. It's an arbitrary list that people who've had a lot of wine to drink before their lunch come up with. So don't start a Twitter campaign to try and raise halide's priority. Honestly, they don't deserve it.